Hello everyone, today we are going to learn how to calculate the arc length of a sector. Now first of all, we need to understand and appreciate the formula arc length S is equals to theta out of 360 multiplied by 2 pi r. Later I'll be explaining what all these symbols mean. And after appreciating the formula, we should also be able to apply the formula to calculate unknown arc length, radius, subtended angle, or perimeter of sector and segment. Alright, let's take a look at the formula in details. So suppose we have a full circle. Alright, what will be the circumference of a full circle? Alright, so the circumference of a full circle will be given by this formula. Circumference is equals to 2 pi r. We've learned this in primary school before. Alright, so if we take a look at the arc length, what does an arc length mean? Arc length is just part of a circle. Right, it's the outermost part of the circle that is formed by a curved line here. Right, so this curved line AB is actually called the arc length of the circle, and we sometimes denote it by a symbol S. Now, from the arc itself, we will see two lines that is joined at the center. Right, so when two straight lines actually join together and they form an angle from an arc, this angle here is called the subtended angle. Right, I'll just circle it. This angle here is called the subtended angle. And usually we will actually label this subtended angle as a symbol theta. Okay, how do we write the symbol? Okay, it's like a big O here with a stroke in the middle. Right, so this subtended angle is usually labeled by the symbol theta, and it's written like this. Right? Okay. Now, if we already understand that the circumference of a circle is given by 2 pi r, then it's not difficult to understand that the arc length is actually given by theta of 360 multiplied by 2 pi r. Why is it so? Okay, we can imagine that the full circle is having a total angle of 360 degrees. This is the angle for a full circle, right? And because the arc length is part of a circle which is extended open by the subtended angle, right? So it will just be a proportion of the circle. So in other words, theta out of 360 will be the proportion of the region, okay, that is extended by the subtended angle. And in this sense, the arc length will just be the proportion of the circumference of the circle. So this is how we can actually easily remember the formula for the arc length. Okay, so arc length will just be equal to a proportion of the circumference of a circle. Okay, and in written form, it will be S equals to theta out of 360 multiplied by 2 pi r. This is how we can remember the arc length of a circle. Right, let's take a look at an example now. Now, suppose we have an unknown circle. Suppose we have a sector over here and we are asked to find the length of arc AB, where O is the center of the circle. So how do we actually find the arc length in that case? So we'll just apply the formula. S is equals to theta over 360 multiplied by 2 pi r. Okay, so substitute all the values inside. Okay, theta will be 160 degrees. The radius will be 7 cm. So we'll substitute all these unknown values inside now. Given value, sorry. Okay, so your arc length is the unknown value. We substitute 160 into theta. And we substitute r with 7. Okay, so press your calculator now. Alright, and after pressing your calculator, you will get a value of 19.5477. Okay, if a degree of accuracy is not given, we'll round off the radius, the arc length, to 3 significant figures. So in this case, the arc length will be 19.5 cm, rounded off to 3 significant figures. Okay, so this will be how we calculate the unknown arc length. Okay, so the unknown arc length is very easy. We just apply the formula straight away and we can actually get our answer. Right? Let's take a look at the second example. Okay, in this second example, we are actually given the arc length and the subtended angle. Okay, and our job now is to actually find the radius of the sector. So same thing, we'll apply the formula. Okay, write down the formula for arc length first. So S is equals to theta over 360 multiplied by 2 pi r. We'll fit in all the given values now. So the arc length is 45 cm. We'll fit in the arc length. The subtended angle will be 145 degrees. So we'll put in 145 as well. Okay. And the unknown radius, we'll just leave it as it is, as r. Now, to calculate the value of r, right, first of all, we want to calculate all these given values first. Right? We'll leave pi alone. So we'll just take 145 over 360 multiplied by 2. Right, and after doing our calculations, we'll get a value of 29 over 36. So 45 will be equals to 29 out of 36 pi r. Okay, so if we want to actually visualize this clearer, we can actually flip the sides around. So now 29 out of 36 pi r will be equals to 45. Now, if we want to find the radius, then we need to remove 29 out of 36 pi. Okay, how do we remove it? We will divide by 29 out of 36 pi. Okay, so r will be equals to 45 divided by 29 out of 36 pi. Right, and after pressing our calculator, rounding it off to 3 significant figures, our answer will be 17.8 centimeters. Okay, so this is our answer for this question. Right, okay, so just a quick recall again. So to find our unknown radius for this question, okay, what we'll do is we'll first write down the formula for arc length. Right, and we will actually put in all our given values, okay, the arc length as well as the subtended angle. Right, then after that we will just calculate all the numerical values, okay, and we'll simplify it in the form 29 out of 36 pi. Okay, to find the value of r, we'll just take 45, divide by all these values in front of r, or the coefficient of r for that matter. Right, so r will be equals to 17.8 centimeters. Right, we take a look at the next example. Okay, in this example, we are supposed to find the unknown subtended angle, right? Given the arc length as well as the radius of the circle. So same thing, we'll apply our formula. Write down your formula. Okay, again, we will fill in the given values. So the arc length is 15. Subtended angle is unknown. We'll leave it as it is. And the radius is 4 cm. Right? Okay. So now do the same thing. We will actually multiply the values. Okay. 2 times 4 divided by 360. Okay. We will just key in all the values into our calculator. Right. And after keying in our calculators, we will get 15 is equals to 1 out of 45 pi, okay, theta. Right, so basically we take 2 times 4 divided by 360, we'll get 1 out of 45. The pi will just follow through, and theta will be the last one to be written. Right, okay, so same thing, we can actually shift it around. So 1 out of 45 pi theta is equals to 15. Right, so to remove the coefficient of theta, we'll just take 15 divided by 1 out of 45 pi. Okay, and angles, we'll leave it to 1 decimal place. Right, so after pressing our calculator, the answer will be 214.9 degrees. Okay, we round it off to 1 decimal place. Right? So same technique, we'll write down the formula for arc length first, fill in the given values, and after that just consolidate all the numbers, and after that we will just divide by the coefficient of theta to find our answer. Okay, so this is how we find an unknown subtended angle. Okay, very easy, right? Okay, let's look at the next example. Right. So in the next example, we want to actually find the we want to find the unknown parameter of a sector. Okay, so to find an unknown parameter, right, first of all, you need to know how many lengths we are interested in. Okay, so take a look at the example over here. Okay, how many lengths are we interested in? 1, the arc length, 2, the radius, and 3, the radius OB. Okay, so again, how many lengths are we interested in? Okay, the arc AB, that's the first length. Second length, the radius OA. The third length, the radius OB. Okay, so we are interested in a total of 1, 2, and 3. 3 lengths. Okay, so first we find out what is the length of arc AB first. Right, so arc AB will be given by theta of 360 multiplied by 2 pi r. Okay, we fill in the given values. So 305 out of 360 multiplied by 2 pi multiplied by 10. Right. Okay, so we will get a value of 53.2 centimeters. To find the parameter, we'll just add in the 2 radius as well. Okay, so the parameter will then be given by 53.2 plus 10 plus 10. Right, so we add them together, we will get 73.2 centimeter. Okay, this is rounded off to 3 significant figures. Right. Okay, so to find the parameter of a sector, then first of all we need to calculate the arc length using the arc length formula. And once we are done with the arc length formula, we'll need to just add in the 2 radius to be able to calculate the full parameter of this sector. Right. Okay, let's look at another example. Right, so right now we have a sector over here, and the region over here is actually called a segment. Okay, the region over here is actually called a segment, which is actually divided by a chord of the line, chord of the circle. Right. Okay, so when we have a segment over here, then how do we actually calculate the parameter? So again, look at how many lengths we are interested in. Okay, so first length is the arc length. Second length is this straight line, the chord of the circle. Right. Okay, so we are interested in 1, 2 lengths. Okay, we are interested in 2 lengths. Right. So let's calculate the arc length first. Okay, so the arc length, okay, will be given by 65 out of 360 multiplied by 2 pi multiplied by 8.8. Right, and after calculations, you'll get a value of 9.983 centimeters. Right. Okay, so the next length that we are interested in will be this chord over here. Right, so this chord can be calculated using cosine rule. Right, because this length over here is actually the radius of the circle, and therefore it will also be 8.8 cm. Okay, so with 2 given lengths and an included angle, we can apply our cosine rule to find this length here. Right, so now we will let's call this length A. Right, so now A square will be equals to 8.8 square plus 8.8 square minus 2 times 8.8 times 8.8 cosine 65 degree. Right. Okay, so we can find the length A straight away, okay, by taking square root. Right, and length A will be 9.456 centimeters. So to find the parameter of the segment, then what we'll do now is we'll take the arc length, okay, and we add it to the length of the chord. Okay, so the parameter will be 9.983, okay, plus 9.456. Okay, so add these two lengths together, right, and we'll get a value of 19.4 centimeters, rounded off to 3 significant figures. Okay, so just a quick recall again. To find the parameter of a segment, then we will need two lengths. Okay, the first length will be the arc length, and the second length will be the length of the chord. Okay, arc length can be obtained by using the arc length formula, and the length of the chord can be obtained using cosine rule. Okay, and after finding these two lengths, we just add them together and we'll be able to find the parameter of the segment. Okay, right, so that's all for the lesson on arc length. Hope you have learned something. We'll see you next time.